then we should configure IP address 10.122/24 with and no shutdown. Again, we have interface loopback 0 with IP address of the quad 2/32. Let me check the interface status, show IP interface brief. As you can see, the ETH11 now has an IP address and also loopback 0. Let me first check the connectivity between these two switches. Ping from switch 1 10.122. Okay, as you can see, yes, we have connectivity between these two switches. Now we can enable the OSPF in NXOS. Don't forget, the first command for configuring the OSPF is the feature OSPF. If you don't configure feature OSPF, you don't have the router OSPF command. Okay, first you should enable the feature OSPF. Okay, and you need the license of the enterprise service. Okay, enterprise service license. If you have this license, you can continue with the configuration of the OSPF. Very good. Let's start with the router OSPF. Here we should use a tag. Tag can be a number, can be a character, can be up to 20 character word. Here I'm using the router OSPF. For example, don't forget the OSPF tag can be different in these switches and can be same. It's not important, but it's better to using the same tag in all of the routers in the, for example, in one enterprise. Router OSPF A. Okay. Now we configured the OSPF. If you want, you can use the router ID command. Let me to configure router ID in this router. Router ID, for example, can be quad 1. This is the router ID of in this router. Now we have OSPF A with the router ID of quad 1. Okay, these two commands. Now we need to configure OSPF on ETH11. Let's go to the interface ETH11, enabling OSPF with this command, IP router OSPF. Don't mistake with IP OSPF command. The command is IP router OSPF. IP router OSPF, then we should use the tag. The tag is A. You know that the tag is A. Please enable the router OSPF process A with the area of, for example, 0. This is area 0, as you can see in the figure. IP router OSPF A now is enabled on this interface, and also we should enable OSPF on the interface loopback 0, IP router OSPF A area 0. This is the configuration of the OSPF on the switch 1. Let me to show you some detail about this configuration. First, show IP OSPF interface brief. Let me to check the show IP OSPF interface brief. As you can see, OSPF process A in the VRF default, in the first VRF, okay, now is enabled, and total number of interfaces enabled with in OSPF is 2, okay, are 2, and that interfaces are ETH11 and also loopback 0. The ID is 1. This is the first interface, and this is the, for example, second interface. And also we have we enabled OSPF on these interfaces in areas quad 0. Don't forget that I configured area 0, but here we can see the dotted decimal notation. Every time you show you use show command in the OSPF, you will see dotted decimal notation. And also, as you can see, the cost is 40 for the ETH11. Let me first finding the, for example, the bandwidth of the ETH11. Show interface ETH11. Show us that this interface ETH11 is a gigabit Ethernet. 1 million kilobit per second means 1 gigabit per second. In OSPF, in NXOS, let me to explain this. In the OSPF in NXOS, okay, we are using the reference bandwidth, okay, for calculating the autocast as 40 gigabit per second by default. In iOS, we are using 100 megabit per second, okay? Because of that, for example, interface with 1 gigabit, the cost of, for example, ETH11 now is 40G over 1G, okay, because this is the 1G interface and the autocast is 40G. You know that the cost in OSPF is equal with the autocast reference bandwidth over the interface bandwidth. Because of that, now the cost of this interface is 40. Because of this, here we have show IP OSPF interface brief. This interface cost is 40 and the cost of loopback 0 is 1. Also, again we have the same concept of DR and BDR, because this is the for example Ethernet links with the broadcast type. Okay, the state of this interface now is DR, designated router. Why? Because we didn't configure the NXOS2, we only configured the NXOS1, and NXOS1 now is selected as the DR. The type of loopback 0 is loopback. This is same as the iOS. And also we don't have any neighbors on the ETH11 until now, and we don't have any neighbors on the loopback 0. And also the status of these interfaces now are up. Very good. This is the initial verification for the interfaces. Show IP OSPF interface brief. If also you want, you can use the show IP OSPF interface, for example ETH11, for seeing the detail about this interface. ETH11 now is in up status. Line protocol is up. The IP address is 10.121/24. Process IDA means I enabled OSPF with process A on this interface in the VRF default. The area is quad 0 or 0. Enabled by interface configuration. You know that I enabled IP router OSPF tag area ID on this interface. The state of this interface is DR. As I mentioned before, the network type is broadcast because this is an Ethernet link. And also the cost of this interface is 40, as I explained before. Index is 1. This is the first interface. Transmit delay is 1 second. It's not important for us, many of these features for now. Router priority is 1. This is the priority of OSPF on this interface. You know that by default the priority of interfaces in OSPF is 1. We can change it. Designated router ID is quad 1 with the address, with the IP address of 10.121, this interface. And we don't have a backup DR or BDR until now. Because of that, you can see that no backup designated router on these networks. 0 neighbors, okay, flooding to 0, adjacent with 0. Okay, timer interval, hello time, same as the iOS, is 10 seconds by default. Dead time is 40 seconds by default. Wait timer for selecting DR and BDR by default is 40 seconds, such as the dead time. And retransmit interval is 5 seconds. All of these timers are same with the iOS. And the next hello should be sent in the 5 seconds later. We didn't enable authentication, no authentication. Number of opaque link LSA 0, checksum, okay, 0. Very good. This is the initial verification. Show IP OSPF neighbors. And also we can see show IP OSPF neighbor, and we don't have any neighbor. Show IP OSPF database. This is the database of switch 1 until now, and you know that the content of the database is same as the content of database in the iOS. This is the router link state or LSA type 1. You know, link ID is same as the router ID of the advertiser router, and some other parameters. All of the contents here are same with the content of the LSDB in the iOS. And finally, if you check the show IP route, okay, you can see that here we have only the connected and also the directly connected and so local routes. We don't have any OSPF routes until now because we didn't enable OSPF on the NXOS. To look at here, quad 1/32, okay. For this pass, we have 2 routes. The first is local because this is the /32 route, the local, and also directly connected. And for 10.120, we have 1 attached or directly connected, and for 10.121, also local route. We don't have any OSPF route. Very good. Let's configure the switch 2, but before them, it's good to see the show IP OSPF result. Show IP OSPF is a command to monitoring all of the features about the OSPF itself. Show IP OSPF. Look at here. Show IP OSPF should give us many features about many information about the OSPF, but one of them is important for me now, and that is the reference bandwidth. As I mentioned before, the reference bandwidth by default in OSPF is 40 gigabit per second.